Welcome students, in this class we will be learning about divisibility tests. Now this is very important and crucial also in understanding what sort of divisibility test can be applied to numbers. Now this topic can be used to a greater extent in competitive exams, specifically if you are trying to get into IT companies or even employments in the public sector. Such questions connected with divisibility will always keep popping up and keep occurring. So this is a very important topic as such, and let's get started. Now first thing is divisibility test for 2. So that means if a number is divisible by 2. Now since 2 is an even number, if the ending digit, right, so that has to be, so let me just state it like this: the last digit of the number in concern should be a even number or a 0. So this is the requirement. Say for example you are taking 472. The last digit is an even number and it is divisible by 2. And suppose you are taking 5020. This is divisible by 2 because the last digit is a 0. So everybody knows this. There's no big deal about this. So let me just go and show you the next one. So test for 3. When exactly a number can be divisible by 3? Now suppose you have a number like this, say 1, 2, 3, 5, and they want to know if this number is divisible by 3. Now what you have to do is foremost add all the digits: 1 positive, 2 positive, 3 positive, 5, and what do you get? This is 3, 3 plus 3, 6, 6 positive 5 is 11. Now check if 11 is divisible by 3. No, it is not. So this number is not divisible by 3. Now suppose instead of 1, 2, 3, 5, if the number is a little bit different, say instead of having a 1, I've got a number 4 there. Instead of having a 5, I have the number 6. So is this number divisible by 3? So let's check that out. All you need to do is add 4 with 2 with 3 with 6. So what do we get? 4 with 2, 6, 6 with 6, 12, 12 added with 3 gives me 15. So 15 is divisible by 3? Yes, it is. Now just for the sake of understanding, let me show that it is truly indeed. So you got 4, 2, 3, 6, you're dividing by 3. 3 divides 4 once, 12, 3 divides 12 4 times, and you bring the 3, 3 divides 3 once, and you bring the 6, 3 divides here 2 times. So 1412 is the solution. So for this, so just to have a recap, what should you do? You should find the sum of all digits, and if it is divisible by 3, in other words, sum of all digits, if I were to write it like this is the best way to write it: sum of all digits should be concurrent to 0 mod 3. Writing it in set theory notation, but I hope you got the gist of it. So this is for divisibility by 3. Now next let me move on to test for the number 4. So when exactly the number can be divisible by 4? Say suppose you have 7428. Now you take the last 2 digits. If the last 2 digits, say in this case is 28, if it is divisible by 4, then the entire quantity is divisible by 4. So you are going to be checking only for the last 2 numbers. Now instead of last 2 digits being divisible by 4, suppose you have the last 2 digits to be 0, 0. Is it divisible by 4? Yes, it is indeed. Now you can check this out. You take 74, 0, 0, and you divide it by 4. 4 ones are 4, you have 34. 8 fours are 32, you have 2. You bring the 0, so it's going to be 5 times 4 5s are 20. You bring the 0, and that's it. So it is divisible. So you can check any number. Say take a random number like this. Say 6 1 3 2 1 and 1 6. Some random number. Now I'm taking the last 2 digits. I need to check this out. Is the last 2 digits, is it divisible by 4? Yes. This is indeed divisible by 4. 4 times 4 is 16. So I'm going to show you that this number is indeed divisible by 4. So let me just take that down. 6 1 3 2 1 1 6. I'm dividing it by 4. 4 divides here once. 2 6 5 4s are 20. You bring a 1 down, and then you got a 3, and then 4 times 3 is 12. You got a 1, you bring a 2 down, then 4 times 3 is 12, you bring a 1 down, so it doesn't go, you bring another down, so 4 times 2 is 8, 8, 9, 10, 11, there's a 3 there, you bring the 6 down, and 9 4s are 36, right? So this number is divisible by 4. So when you divide this by 4, you get 0 mod 4. You can check that out. So the condition for divisibility by 4, the test of divisibility by 4 is the last two digits should be divisible by 4, or it should end in 2 zeros. It should definitely end in 2 zeros. Okay, so it can either be 2 zeros or even more than 2 zeros. But the requirement is definitely there should be 2 zeros in numbers like this. Now next is divisibility test for 5. Now everybody knows 5. So if it ends with 5, if it ends with 5 or 0, the number is divisible by 5. So no big deal. Now we have to check for divisibility by 6. So test for 6. Now for 6, the number should be divisible by 2 and by 3. So that is the requirement. So by 2 and 3. So these two things should qualify. Only then the number would be divisible for, in other words, only then you can clearly say the number is divisible by 6. Say for example, you want to take 105. Now clearly 105 passes the divisibility test for 3, because 1 plus 0 plus 5 is 6. 6 can be divided by 3. Okay, so that is the divisibility test for 3. But 105 is not divisible by 2. So this would mean this cannot be divisible by, so you're not going to get 0 mod 6 in this case. This is not going to happen. 105 is divisible by 3, but it isn't divisible by 2. You can check it out. So 105 is odd, 5 is an odd number. So that in turn would mean 105 is not divisible by 6. So if you were to try this, say 105, I check it out with 6 in fact. 6 ones are 6. I have a 45. No, it's not going to work out. So let me take another random number. Say 1, 1, 2, 3, and 5, 8, 9, 10, 11, 12. Okay, let me not take a 5. If I were to take, let me take it as a 6. 6, 9, 10, 11. Instead of saying 1, I'll take it as 0. Okay, just for sake of illustration. Now let me check for divisibility by 3. So it's going to be 1 positive, 2 positive, 3 positive, 6. 6 plus 3 is 9. 9 and 10, 11 and 12. So you're getting a 12 here. So 12 is divisible by 3. So this is the divisibility test for 3. It holds good, but this is an even number. So this also holds good for 2. So that would mean 1 0 So this would mean 10236 is divisible by 6. And you can check that out. Now let me just use a space here. So 10236 divisible by 6. 6 divides here one time. 4, 42, 6 sevens are 42, 3 doesn't go, 36, 6 6 are 36. You see that? It works like magic. So the requirement is the number has to be divisible by both 2 and 3. Then you can confirm that the number is going to be divisible by 6. Okay, the next one is divisibility test for the number 7. Now say for example you are given this number 658. Now what you got to do is take this digit in the unit place and multiply it with 2. And now whatever that remains here, place that and then perform a subtraction. Now if what you get, see what is this? This is nothing but 65. 8 times 2 is 16. And what do you get? This is going to be 9. And if I take away 1 is 4, 49. So if the number that you're getting, if this is divisible by 7, then this entire number is divisible by 7. So I hope you're catching the essence out of it. So take the unit digit, multiply by 2, and then take the other digits, perform a subtraction. The number that you're getting, if it is divisible by 7, then the entire number would be divisible by 7. Now clearly you can see this number is divisible by 7, 658. Now let me check another number. Say I've got 999 and 5, 4 9s and a 5. It's a 5-digit number. So take the last digit, multiply by 2, perform a subtraction for these 4 9s. So I've got 9 9 9 9. 2 times 5 is 10. So I get a 9 here. 9 take away 1, 8, 9 9. So what do I get? I get 9 9 8 9. So this has to be divisible by 7. So let me use the space here. So 9 9 8 9. I'm going to check it. 7 times 1 7. So 29. 7 times 4 is 28. I carry 1. 7 times 2 is 14. You get a 4. Bring the 9 down. 7 sevens are 49. So this is divisible. This is giving me 0 mod 7. So this is divisible by 7. The question is this number 99995 is divisible by 7? So we got to make a check. So let me have this check done over here. So I get a 4 9s followed by 5, and I need to check for divisibility by 7. So 7 1s are 7. I get a 29. 7 4s are 28. I get a 1. I get a 9. 7 times 2 is 14. I get 5. I get a 59. And then 7 8s are 56. And I get a 35. So 7 5s are 35. So that's true. So I hope you caught the gist of it. How to obtain the divisibility test for 7. So we are finished with 2, 3, 4, 5, 6 and 7. So we have to go for 8 and 9. Okay, so this is the divisibility test for 8. Now usually when you are checking a number for divisibility for 8, definitely the number would be greater than 3 digits, right? So minimum would be 4 digits, because anything else lesser than that you can easily find out whether the number is divisible by 8 or not. So let us assume that you are given a 4-digit number and you want to check the divisibility test for 8. Now all you need to do is take the last 3 digits 2 5 6 and find out if this is divisible by 8. Now clearly 8 times 3 give me 24. I get a 1 remainder. 8 times 2 is 16. So since the last 3 digits are divisible by, in fact, and the number made from the last 3 digit is divisible by 8, this would mean that this entire number 2256 is divisible by the number 8. Now you can check it out. So if I were to say 2256 and I am using division, so 8 times 2 is 16. I get a 6 here, 65. 8 8s are 8 times 8 is 64. I get a 1. I bring the 6 down, so it's going to be 282. So clearly 8 divides 2256, 282 times. Now instead of 2256, suppose you have stacks of zeros. Say suppose you have a number like this, say 4362000. Now it has 3 zeros at the end, 3 zeros. So whenever you have 3 zeros like this, clearly the number will be divisible by 8. You got 3 zeros like this, the number will be divisible by 8. You can check this out. Now let me take a random number. So I'm going to take a random number like say 121000. This is a random number. Okay, just because it has got 3 zeros, I'm coming to the conclusion that this number is going to be divisible by 8. So let's check that out. So 8 ones are 8, so I get a 4, right? And then I bring the 1 down, so 8 times 5 is 40, right? So I get a 1 here, I bring the first 0, so 8 ones are 8, I get a 4 here, I bring the next 0, so 8 times 5 is 40, and I get another 0, I'm bringing it down. So this is the quantity. You see how beautiful it is? 8 divides 121,000,15150 times. You can check that out. Clearly we can see that. So this is the test for divisibility for the number 8. Okay, let's finish it up with the divisibility test for 9, 10 and 11. Now if you are given a number, if it is required that you find the divisibility check for the number 9, it is very simple. All you need to do is add up the digits. Now if the quantity that you are getting, if it is divisible by the number 9, then the entire number is divisible by the number 9. Simple as that. Now in this case 4 added with 3 gives me 7. 7 added with 5 would give me 12. 12 with 6. 12 with 6 gives me 18. So 9 times 2 is 18. So clearly this number is divisible by the number 9. You can check it out. Say for example I got 4, 3, 5, 6. I got 9. 9 4s are 36, you get a 7. 8 times 9 is 72, you get a 3 and a 36, so it's 4 times. So that is all you need to do for the number 9. Now the test for number 10 is the last digit should be a 0. The last digit should end with a 0. That is all you need for divisibility test for the number 10. Now the test for 11. Now the sum of odd digits should be equal to sum of even digits. That's it. Or it should differ by a number which is divisible by 11. Probably the best way to do is to show by an example. So the requirement is the sum of the odd digits should be equal to the sum of the even digits, or the values that we get for the first part and the second part can differ by a number which has to be divisible by 11. So let me just show you the first condition. Say you got 121. So what are the sum of the odd digits? In the odd digits are 1 and 1. So that's equal to 2. Now what is the sum or the number that you got in the even digit? It's 2, right? So clearly 2 is equal to 2. So clearly 121 is divisible by 11. So this is based on the first requirement or the first condition. Now let me show you the second condition, or how exactly the second condition comes into play. Suppose you have a number like this, 217382. So take out all the digits in the odd places. So sum of odd digits. So what do you get? You get odd digits. This is in the odd digit, this is the odd digit, this is the odd digit. So it's going to be 1, positive 3, positive 2. And what is the sum of all digits in the even places? Sum of even digits. So what do you got? Even digits 8, and then 7, and then 2. So let me add them. 3 plus 2, 5, 5 plus 1, 6, and 7 plus 8 or 8 plus 7 is 15, 16, 17. Now 17 minus 6, what do you get? 17 minus 6 is 11, and 11 is clearly divisible by 11. So this number 217382 is divisible by 11. You can really check that out. I can show you. 217382. 11 ones are 11, 0, you bring 1 down, 7, and 11 times 9 will give you 99, and this is going to give you 8, and you can bring the 3 down. 7 times 77, this is going to give you 6. You bring an 8 down, this is 66. 2, this is 2, 22. Okay, so this is the condition that I've applied, and I got the result. So let's move on to the next test. So the next one is the divisibility test for the number 12. Now a number is divisible by 12 if it is divisible by 4 and it has to be divisible by 3. Now take for example, so let me just take this number 2244. Now for this number to be divisible by 12, it has to satisfy the divisibility condition or the divisibility test by 4 and the divisibility test by 3. Now the divisibility test for 4 is what? The last 2 digits should be divisible by 4. Yes, it is. Now to check the divisibility for 3, the sum of the digits should be divisible by 3. So 2 plus 2 plus 4 plus 4. What do you get? 2 plus 2 is 4, 4 plus 4 is 8, 8 plus 4 is 12, and clearly 12 is divisible by 3. So clearly 2244 is divisible by 12. Probably you can see that. So 12 ones are 12, you get 0 and 1 and 4. 8 times 2 is 16, 1, 8 ones are 8, 96. This is going to give you 84 and 7. 7 times 2 is 14 and you get 84. So clearly you can see that 12 divides 2244 187 times. So this is a beautiful test. Now the next one after the divisibility test for 12, we have to check the divisibility test for the number 14. So test for 14 is that the number has to satisfy the test for 7 and the number has to satisfy the test for 2. Now clearly you can find out any number divisible by 2. It has to be an even number or it has to end with 0. And with regard to 7, clearly we also know how to check that for. So let's go on with that. So let me just take this number 1232. So I'm checking the divisibility test for 14. So if a number is divisible by 14, it has to satisfy the divisibility test for 7 and the divisibility test for 2. Clearly the number will be divisible by 2 in this case because it is an even number. But for 7 we need to check if 2 times of this quantity and subtraction being performed between 1, 2, 3 and this results in a number which is divisible by 7. So that's exactly what we have to do. So 1, 2, 3 is here and I take away 4. So this is going to give me 9 and I get a 1 and a 1. So what am I getting? I'm getting 119. So question is 119 divisible by 7? That's what I need to check. So 7 ones are 7. I get a remainder 4, 49. So 7 times 7 is 49. Right? So clearly this number is divisible by 14. So let me just show you that this number is divisible by 14. So let me try the division. So 14 doesn't divide 12. So 14 divides 1, 2, 3. How many times? 6 4s are 24, 7 2s are 14, 1, 8 times, 8 4s are 32. Let's check it out. 8 4s are 32, 3, 8 2s are 8, 9, 10, 11. So I get a 1, and 2, 88 times. Bravo. So you can clearly see that how exactly by knowing divisibility test we can just zero in our solutions just instantaneously like that. So next is for a number to be divisible by 15, it has to satisfy the test, pass the test for 5 and pass the test for 3. Okay, these two things should be satisfied, and we can easily see that. Say for example you got 1275. Now clearly this is going to be divisible by 5, right? But for divisibility test for 3, I need to sum up all these things. 1 plus 2, 3, 3 with 7 gives me 10, and 10 with 5 gives me 15, and clearly it is divisible by 3. So this number 1275 is divisible by 5 and 3. So that would mean this number will also be divisible by 15, which we can clearly see. So 8 times 44, 8 ones are 8 times, say 8 fives are 44, 8 ones are 8, 9, 10, 11, 12, and you get 75. And 75, how many times? 5 times, right? 5 5s are 25, 2 5s are 6, 7, 75. So clearly 15 divides 1, 2, 7, 5, 85 times. So that is the test for 15. So we have completed up until 15. Let's go and check the divisibility test for, let me write it down. This is the test for the number 16. Now in 16, what we have to do is, say suppose you are given a number like this, 1 2 6 3 0 4. Now in order to ascertain that this number is divisible by 16 or not, you need to take the last 4 digits. Now these last 4 digits should be divisible by 16, and if the condition holds good, then the entire digits or the entire number is divisible by 16. Now let me just show it to you. So 6304, I got a 16 here. Okay, 3 times 6 3s are 18, 1 3 on the throw 4, 48, and I get a 5 there, and I get a 1 there, I get a 0 there. So you get 9 times 54, 5. So you get 150. So if I were to place 9 6 are 54, 5, 9 ones are 9, and you get 144, and this 6 and 4. So clearly 4 times. So the last 4 digits clearly shows that the test for 16 is satisfying. So that would mean 126304 is also divisible by 16. So maybe you can check that out. So let me just show that to you. 126304 is indeed divisible by the number 16. So 16 cannot divide 12, but 16 can divide 126. So I want to find out 8 times 48, 4, no, 7 times 7 6 are 42, 4. This is 11. You get a 4 there, you get a 1 there, you get a 3 there. 8 times 42, 6 8s are 48, 4, 9. Probably I can give 9. No, it's 8. 6 8s are 48, 4, and 8 ones are 8. So 128 you get. This is going to be 15 and 1, and you get a 0 there. 9 times, with the 9 times, if it is 9 times you get 144, 9 times, and then the remainder is 6 and a 4 and 4 times. Yes, 126304 is indeed divisible by 16. So that is the divisibility check for the number 16. Let's move on. Probably I can give you one more test. This is test for 18. Now for a number to be divisible by 18, it has to be an even number, and then it has to satisfy the test for 9. So if these two tests are holding good, then the number is divisible by 18. Say for example you have a number like this, 936198. Now this is an even number, and that condition is satisfied. Next is we will have to find out whether this number is divisible by 9. So I need to add up the digits. So 9 plus 3 plus 6 plus 1 plus 9 plus 8. Now 1 added with 8 will give me 9. So I have a 9 here. This is a 9 and this is a 9. So clearly this is divisible by 9. So that means this number is divisible by 18. So that's the way you have to move forward. So students, with all this divisibility test, we will wrap up for today's class, and we will meet again. Thank you students. Enjoy your day.